Okay, welcome students. So today we are going to see what eccentric welded connections are. Now, suppose we are taking a steel member or a structural steel member which consists of an I-beam. So these two lines represent the plan, the top plan of an I-beam, and this I-beam is connected with a gusset by the help of a welded connection. Okay, so the welded connection is basically represented by this violet line. This is the length of the weld, this, and this. This is the total length of the weld, and this welding or this welded connection is connecting this gusset plate to an I-beam, to the top or the bottom of an I-beam. Okay, now suppose a force is being acted on this gusset plate or on this structural member at this location. Okay, suppose a force is being acted on this structural steel member at this location. Let me write down the force P. P is acting on this gusset plate at this location, but the center of gravity or the CG of this welded connection is lying somewhere around here. Suppose the CG is lying somewhere around here, so I can represent location of the CG with the help of X and Y axis. Suppose this is the X axis and this is the Y axis or the Y axis, and this point over here, this point is the location of CG. Okay, so now we can see that the load is not exactly acting at the location of the CG or the line along which the CG is passing. So what does that mean? It means that the load is acting at a certain distance from the CG, and we can assume that distance as E. Okay, so this distance over here, this is E. Okay, let me write it down. Okay, so this load P is acting at a distance C from the location of CG of this welded connection. Now what will happen? Due to this externally applied load, two loads will be acting. Two shear stresses or two loads due to shear stress will be acting along the length of the weld, along any length of the weld. Let us suppose we are assuming an element which is denoted by this small black rectangle. Okay, suppose this is an element along this length of the weld, and we'll see what are the forces or what are the resultant forces that are acting due to the externally applied load. So the first load that will be acting, or the first stress that will be acting, is given as the shear stress due to direct load. Okay, and okay, so first let us see what is this direct load. So this welded connection, which has a load acting at an eccentricity E, we can draw an equivalent loading arrangement for this connection. Okay, so let us see what this equivalent loading arrangement will be. Now suppose we are marking it as red. This equivalent loaded arrangement can be represented as a load that is acting through the CG. Okay, a load which is acting through the CG, and since there is an eccentricity at which the load is acting, we can we can assume a bending moment which is acting. We can assume a bending moment which is acting about the location of this CG. Now what is the value of this bending moment going to be? It is going to be nothing but P into E. Okay. Okay, so what we are doing here, we are basically taking an equivalent loading arrangement for this type of eccentric loaded connection. In the equivalent loading arrangement, what we have this load, which is basically the direct load, which is acting downward along the CG, and we have an equivalent bending moment due to this eccentric loading, and the value of that moment is going to be P into E. So there will be two forces that will be acting due to this direct load and due to this bending. So the first type of load due to the direct load is going to be shear stress, which is acting due to the direct load. Okay, so let us write it as, let us give the symbol as FD. Okay, this will be equal to nothing but the load which is acting on this member, the load per unit length of this weld. Okay, so L is nothing but the length of the weld. What is the length of the weld? It is nothing but this length plus this length plus this length. Okay, so the direct force or the shear stress due to the direct loading is given as FD, which is equal to P by L. And second one, which is acting due to this bending moment, is my torsional shear stress. The second loading is my torsional shear stress due to the moment PE. Okay, so the torsional stress due to the moment PE, we can write it as Fm. And what will be the formula for Fm? It will be nothing but T into R divided by I or IP. Okay, so what does T, R and IP denote? The T is nothing but the twisting moment. Twisting moment, because of this eccentric loading, the value of the twisting moment will be equal to what? P into E. P into E. What is the R? R is nothing but the radial distance. R is nothing but the radial distance of what? The radial distance of this element with respect to the location of the CG. Okay, and IP is nothing but the polar moment of inertia. Okay, now let us see sorry, let us see what is the what is the direction of FD, that is the shear stress due to direct load, and the direction of FM, that is the torsional shear stress due to bending. So we were considering this element. Now FD will be acting downward. Okay, FD will be acting downward along gravitation or along gravity, and this torsional shear stress due to the moment Fm. Okay, first let me give the annotation FD, and the second shear stress, which is the torsional shear stress or the force due to the torsional shear stress, will be acting at a distance that is perpendicular to the radial direction. Okay, now what is the radial direction? The radial direction is nothing but this. Okay, this is my R. This is my R. Okay, so this is my radial direction, and the torsional shear stress will be acting at a direction perpendicular to this radial direction. Okay, so this is my Fm. Okay, so we are basically considering an we are welding element, okay, and on this welding element two forces are acting. One is the direct force and one is the force due to the torsional moment or the twisting moment, I should say. So these two forces are acting. Obviously there will be going to be a resultant force or a resultant shear stress as a result of these two stresses. Okay, so the direction of my resultant shear stress is like this. This I can write it as, we can symbolize it as FR. Okay, so what is my value of FR going to be? Let me write it down again. My FR will be equal to root over, okay, let me just draw the root over. Root over of FD square, okay, plus FM square plus twice FD FM cos theta. Okay. Okay, so basically this is actually going to be capital F. Please rectify it. Now we have already calculated FD through this formula, which is equal to P by L. We have already calculated FM through this formula, which is equal to T into R by polar moment of inertia. And this portion is nothing but the resultant of these two. Okay, so one unknown we have, that is this theta. So how will you find out theta? Theta is nothing but the angle that is made by this radial distance or this radial direction with the horizontal. So theta is basically this. Okay, so this is my theta. Okay, now this resultant stress, this resultant shear stress is nothing but the stress which is acting on this member due to this factored load or this eccentric load. So this resultant stress should always, the resultant stress, let me again write it down, it should always be less than what? This resultant stress under this factored load should always be less than the design strength of the weld. Okay, suppose sometimes we have to find out what is the adequacy of this section, means whether the section is safe or not, whether the welding, the length of the welding, the size of the welding which is provided to this member is enough to resist the load that is acting eccentrically. So these are my problems. So how will we check whether the connection or whether the design that we have made is safe or not? We have to ensure that the resultant stress or the resultant force due to this eccentric loading should always be less than the design strength of this weld. Now, how will you find out the design strength of this weld? Design strength of this weld can be found out from IS 800-2007. You can write it down. It can be found out from design strength of weld is denoted by FWD, which is equal to how much? FU divided by root over of 3, root over of root over of 3 into gamma MW. Okay, where will you find it? This is given in the code. Okay, IS, everyone knows what is the code for steel, IS 800-2007. Clause number is 10.5.7.1.1 and page number is 79. So this is the theoretical portions and the calculation of the shear stresses, the direct shear stress and the torsional shear stress, and the calculation of the resultant shear stress due to these two different stresses, and whether this section is safe or not. The welded connection that we have provided, we have to check whether this welding is safe enough to carry this load. Okay, so goodbye. Hope you have a good day.